And welcome back to part 2 of the aerial tuner unit. Before putting it together, I thought we'd have a quick look at what's actually in it. And so I've broken it down into like 5 blocks. Got an input circuit, the input cap impedance switching, the inductive impedance switching, and the output capacitance switching, and the processor and memory that controls it all. As you can see, there's some signals coming out of here that go down to here, but I haven't fully buzzed them out. That might be in another episode. So if we move down, look at here, what we have is the RF signal from the radio comes in here. First thing it does is it comes down here and it goes into a 40-40, let's just check, zoom in a bit, a 40-40 divider. So you see, it knocks down the incoming frequency into a frequency that the microcontroller can handle. Right, this bit is effectively, zoom in again, get used to it. It is effectively producing a voltage that's proportional to the reverse power and the forward power. So this gives an indication of the impedance of the antenna. If this point here was 50 ohms and we were feeding 100 watts in, and it's fed from 50 ohms, the impedance here is 50 ohms, then the 100 watts will all flow down there. We'd have an indication of 100 watts forward power and no reverse power. If this impedance is different, then some power will bounce back and we will get a higher reverse power. And the extra windings on the transformer and this transformer here, the outputs combine and it gives us a voltage that is proportional to the resistance of the antenna. A portion of that signal is fed through this balance mixer and we get a voltage out that is proportional to the phase of the signal. So that's what's happening in the input circuit. That then passes on effectively to here. We have a ULN 2003, and so effectively this is the input bus from the microcontroller, and we can switch each relay on as required. And as you can see, the RF signal comes in and it can go through that capacitor, through the relay down to the ground, and so you can switch the capacitors in parallel, and effectively they double. So that one is 100 puff, 200 puff, effectively 400 puff, 800 puff, 1600 puff, and 3200 puff. So that's input capacitor switching. The inductive one, there's what, 1, 2, 3, 4, 5, 6, 7, 8. And there's only 7 channels on the switch. So the 7th channel on the capacitor switch feeds through and becomes the first channel of the inductor driver switch. And again, 1, 2, 3, 4, 5, 6, 7, 8 relays, and this time you're shorting out the inductance. If all the relays were open, all the inductance adds up, but as you close a relay, you take that inductor out of the equation and lower the inductance. And again, if you look at it, they're in sort of like a factor of 2, so 0.25, 0.5, 1, 2, 4, 8, 16, 32. So that gives you the smallest step of 0.25 microhenries. So that's the inductance side of it. Try and keep control of it. And here is the output capacitance side. So effectively again, we have 5 capacitors, and again, they go up in 2s, 25 puff, 50 puff, 100 puff, 200 puff, 400 puff. And I think as you saw in the first one, these are 3 kV capacitors, because you can get some sillily high voltages on the antenna if it's not matched. So that's the capacitance side of it. And of course, that's the measuring side. Effectively, that is a pi matching circuit, capacitors to deck, inductors in series, capacitors to deck, and then the output goes out to the antenna. I haven't drawn much. I'm still a work in progress, still looking at the microprocessor and how it controls the latches for the different capacitors, inductors, etc., and how it interfaces to the memory. The one thing that is puzzling is it uses an AT89C51. Now this doesn't have any analog to digital converters in it, yet the circuit is producing analog voltages from that front end, the measuring side, and I haven't quite drawn out the op amps and that are doing some work from those first signals. It must have a trick up its sleeve in the software for measuring voltages. I can't get at the software, so that will just have to remain a mystery. Anyway, thought I'd just run it through and show you what it looks like to give you an idea of what's actually on the inside hardware wise. Now we'll get on with the build. I won't bore you too much, so a little bit of light music in the background. Enjoy. Well, here we can see it finally encased in its box. ready for the lid to go on. And I just thought I'd like to point out, if you look at the inductors, each inductor starting from the little one top left to the big one top right, each inductor is 90 degrees to the one before it and the one after. This is to stop mutual inductance affecting the values. If you like what you see, please subscribe, hit the bell for notifications, and I'll catch you on the next one as always. Goodbye.